Welcome to Cloud Solutions Podcast, where we simplify the world of cloud technology, one episode at a time.
Hey everyone, and welcome back. Ready to dive deep? Today we're tackling encryption in AWS.
Encryption, always a hot topic, and you provided us with a fantastic resource to unpack.
We have. It's AWS's own encryption, best practices and features for AWS services document.
Consider this your cheat sheet to encryption mastery, whether you're prepping for a big meeting.
Or just a curious mind, eager to level up your AWS security game.
Exactly. So should we jump right in?
Let's do it. First things first. Why is encryption such a big deal, especially now? Generative AI exploding onto the scene, data breaches constantly making headlines.
It's like this, right? Encryption is like Fort Knox, but for your data. Picture this. You're scrambling sensitive information into unreadable code, making it totally useless without the decryption key.
So it's like those spy movies where they intercept messages, but it's just gibberish without the code book.
Exactly. And with things like generative AI using massive data sets, keeping that info locked down is more crucial now than ever.
Makes sense. So like when I buy something online and my credit card details are turned into gibberish, that's encryption.
Bingo! That's encryption in transit protecting data as it moves from point A to point B.
Okay, so it's like a security detail for data on the move, but what about data that's just chilling out, stored somewhere?
You're talking about encryption at rest, safeguarding data stored on systems like S3.
So it's like putting a lock on your filing cabinet?
Precisely. And then there's encryption in use. Imagine protecting data even while it's being actively processed.
Whoa, so even when it's being used, it's still got a bodyguard. This document we're diving into, it covers all these angles.
It does, and get this. It goes beyond the what of encryption, diving into the how with a range of AWS crypto services.
Music to my ears. So we're talking AES, 3DES, RSA, ECC.
You got it. Don't worry, we'll break it all down. No cryptography exams here.
That's a relief. The document sounds incredibly thorough. Where does it recommend we actually start? Because honestly, it feels a bit like a jungle out there.
It's true. There's a lot to unpack. The document is clear, though. It all starts with knowing your data.
Okay, that makes sense. But how do we actually do that?
Yeah.
Not all data is created equal.
Right. You wouldn't protect, say, your shopping list.
The same way you'd protect the secret recipe for Coca-Cola.
Exactly. Data classification is about understanding the value and sensitivity of your information.
So, choosing the right lock for the door based on what's behind it, what comes after we've sorted our data.
Well, the guide is a big advocate for having a robust encryption policy.
Like a blueprint for how our organization handles encryption across the board.
Yes. Think of it as aligning your encryption practices with how you've classified your data.
Okay, and any industry standards or regulations we need to follow.
Exactly. And it goes beyond just what to encrypt.
It's about how we encrypt as well.
Precisely. This is where choosing the right algorithms and key lengths comes into play.
So it's like choosing the right building materials for your data fort. Got to make sure it can withstand those attacks. Speaking of specific recommendations, I love how this document gets into the nitty-gritty for different AWS services.
I agree. It's very practical. And the recommendations are really service-specific.
Which is so helpful. It's one thing to talk about encryption in theory.
It's another to actually see it applied in real-world scenarios.
Exactly.
Take CloudTrail, for example. The guide is crystal clear. Always use a customer-managed KMS key for maximum control, of course, and enable log file validation.
So no one can cover their tracks.
I love it.
What about DynamoDB? It's so widely used.
Absolutely. With DynamoDB, the guide hammers home, again, using customer-managed keys.
And stresses the importance of encrypting data both at rest and in transit.
Layered security essential for keeping that data safe, and this granular approach, it's a common thread throughout, right?
I've noticed. It even gets into the specifics for EC2 and EBS volumes.
For those, enabling encryption by default is key. It ensures that any new EBS volume or snapshot is encrypted right out of the gate.
Love it. Simple but effective. What about Amazon ECR? Container security is becoming so important these days.
Absolutely. For ECR, again, customer-managed KMS keys for that granular control, and it warns against messing with the default grants that Amazon ECR sets up.
Don't touch those settings unless you really, really know what you're doing.
Got it. What about Amazon ECS?
Yes. Containers, containers, containers. The guide dives into how to secure those all-important environment variables within your ECS tasks.
It recommends using AWS Secrets Manager for secure storage and automated rotation. Exactly. It's like changing your passwords regularly, but for your applications. Speaking of sensitive information, what about Amazon EFS?
File systems, they seem like they'd be a juicy target for attackers.
You said it. The guide is all about enforcing encryption for EFS file systems.
And it recommends using the EFS mount helper.
Yes, to make sure those connections are locked down tight with TLS. It also suggests using AWS Private Link for secure communication within your VPCs.
And, of course, locking down those all-important KMS keys with resource-based key policies, layering those security measures.
Absolutely. So many layers, it's like a digital onion. Speaking of layers, we have to talk about Kubernetes and Amazon EKS, right?
It's like a whole ecosystem within AWS.
And when it comes to EKS, the guide really emphasizes securing your secrets within those clusters.
Okay, so if you're using etc., for example, you should encrypt those secrets at rest and be super careful with access control.
Right, using those role-based access control rules, it's all about damage control.
Limiting the blast radius.
Precisely. And here's where things get even more interesting. The guide dives into client-side encryption with the AWS Encryption SDK.
Ooh, the encryption SDK. It's like having the power of an encryption right in your hands.
It's true. The encryption SDK is a powerful tool. It allows you to encrypt data on the client side before it even reaches AWS.
So it's like encrypting your message before you even put it in the envelope.
Exactly. And get this, it even supports encryption in use, so your data has that extra layer of protection while it's being used.
Wow, that's impressive. But with great power.
Comes great responsibility.
You know it.
The guide stresses that it's not about going rogue with encryption, but about leveraging the AWS Encryption SDK's capabilities securely.
Right, so no rogue encryption. What are some specific best practices for using the SDK safely and effectively?
One recommendation is to use wrapping keys to protect your data keys.
Double the protection. I like the way this guide thinks. What else?
It highlights the key ID parameter, especially when using the re-encrypt operation.
Making sure we're using the right key for the right data.
You got it. It's all about preventing accidental use of an incorrect or unauthorized KMS key.
It's like having that extra check at the door, making sure the key actually fits the lock.
And for applications dealing with tons of data, that constant encryption and decryption can get intense. So the guide reminds us about the AWS Encryption SDK's data key caching feature.
Right, we talked about that earlier. It's like keeping frequently used keys handy so you're not making a trip to the key master every time.
Exactly. But always, and the guide stresses this, configure those cache security thresholds carefully. Don't sacrifice security for the sake of speed.
Got it. Caching, yes, but with caution.
Yeah.
Okay, so we've covered using the AWS Encryption SDK for client-side encryption, but now can we talk about AWS KMS itself?
Of course. AWS KMS, it's like the key master of the entire encryption universe, right?
It really is. It gives you the power to create and manage those cryptographic keys that are essential for encrypting and decrypting your data. But how do we actually keep our KMS setup itself secure?
Great question. And the guide is clear on this. Use KMS key policies. They give you that laser-focused control over who has access to your keys.
So it's not enough to just have KMS. You need to lock it down properly.
Exactly. Are you ready for a quick quiz?
Hit me with it.
What are the three main types of keys within KMS?
Okay, let me see. There's customer managed, AWS managed, and AWS owned. Did I get it?
You aced it. And the document is very clear. If you have the option, go with customer managed keys.
They're the most secure and flexible option, right?
Exactly. They give you granular control over everything from key rotation to deletion.
Ultimate power and flexibility. But, as always,
With great power.
comes great responsibility.
You know it. And the guide doesn't shy away from that. It stresses the importance of following the principle of least privilege, especially when we're talking about managing these powerful KMS keys.
Right, no handing out master keys to everyone in the organization.
Precisely. The guide even suggests limiting the use of customer-managed keys to specific AWS services. You can use the KMS via service condition key in your key policy to do this.
So it's like a key card that only unlocks specific doors in a building. Very cool. It's all about being intentional about how we manage those encryption keys.
Exactly. And while we're talking KMS best practices, here's a big one. The guide explicitly advises against using the overly broad KOMS for actions in either IAM policies or key policies.
Okay, KOMS is a no-no. Got it. Why is that so important?
Because it's like leaving the door to your vault wide open.
Yikes. Definitely not the goal.
Not at all. Using TLMS gives way too much permission, both for administration and de-usage of that key. It's like giving someone a key to your house and saying, feel free to rearrange the furniture, make copies of the key, and invite your friends over.
That's terrifying. So instead, we should be laser focused with our permissions, right?
Precisely. Only grant the bare minimum access that's absolutely necessary for a specific task or role, and nothing more.
Trust, but verify, then limit access anyway. Am I right?
You've got the right mindset. And speaking of verification, the guide emphasizes logging AWS KMS API calls in a CloudTrail log.
It's like having a security camera pointed at our KMS keys.
You got it. It provides a detailed record of who did what, when, and from where.
Evidence, just in case.
Oh, yeah.
Okay, any other KMS security essentials before we move on?
One more thing. Encryption context. Useful feature, but be careful. Never, and I mean never, include sensitive information within your encryption context.
Wait, why not? It sounds like a convenient place to store extra details about the data.
I know it seems that way. But remember how we talked about CloudTrail logs being our watchful guardians?
Right, recording all those actions.
Exactly. Those logs, they're stored in plain text JSON files.
Yeah.
And that includes any encryption context you've used. So if someone got their hands on those logs,
They could potentially see that sensitive information. Okay, that was almost a trap. Encryption context useful, but handle with care.
handle with care. I like that. And speaking of careful handling, let's not forget about monitoring.
Right, because you can't just set it and forget it.
Exactly. The guide recommends setting up notifications for any key events, things like key creation, any updates to your customer-managed key policies, even attempts to import key material.
So if someone tries to sneakily create a new key without authorization, we'll be the first to know.
Precisely. You can even take it a step further, automate your responses to these events using Lambda functions.
Wow, so we can automatically disable a key if there's suspicious activity. Talk about proactive security. Now, I've talked a lot about single-region keys. What about multi-region keys? Those sound serious.
They are. Multi-region keys are for those complex scenarios, things like disaster recovery or backups.
Situations where you need your keys accessible across multiple AWS regions.
Right. But because they exist in multiple locations, they need an even higher level of security.
Got it. So multi-region keys are not for everyday use. It's like having a backup set of keys stored in a different location. You don't want just anyone to have a copy.
Exactly. The guide recommends only allowing principals to replicate a multi-region key into specific regions when absolutely necessary. It's all about minimizing that blast radius and following, you guessed it, least privilege.
Loose lips and sink ships?
As keys compromise data.
You got it. Okay, we've covered a lot about KMS types of keys, policies, best practices. It's a lot to take in. What's next on our AWS encryption adventure?
From one critical service to another, how about we shift gears and talk about AWS Lambda? Those serverless functions are everywhere these days.
And they need just as much security as any other service. What does the guide say about keeping our Lambda functions safe and sound?
It stresses encrypting those server-side and client-side Lambda environment variables.
So whether those variables are taking a break or on the move, they're always protected.
Exactly. And you'll be happy to know that Lambda actually has server-side encryption at rest enabled by default.
Okay, that's one less thing to worry about. So it's like having that baseline level of protection baked right in. But what about those times when those variables are in transit? How do we make sure they're protected then?
That's where client-side encryption using helpers comes in. Encrypt those environment variables before they even leave the station.
Like sending sensitive information in a locked briefcase. I like it. But even then, we still need to be mindful of those permissions, right?
Always. Even if they're encrypted, not everyone needs to see those environment variables.
So we're talking about controlling access, even denying the ability to view them for certain users or roles.
Exactly. Minimizing that blast radius. It's all connected. And speaking of connected, let's talk about Amazon RDS.
Ah, RDS. Relational databases, they're the heart of so many applications.
And securing all that data, both when it's stored and when it's moving between systems, is mission critical.
Totally. So give us the rundown. What are the key takeaways for making sure our RDS instances are locked down?
First things first. Choose the right encryption method for your specific database needs.
Because one size doesn't fit all.
Exactly. You have options. Encrypting with AWS KMS keys,
Which we already know and love.
or using transparent data encryption, TDE, if your database engine supports it.
Okay, so different encryption methods for different situations. Got it. But no matter which method we choose, using customer-managed keys is still the gold standard, right?
You know it. Remember, with great power comes great control. And with RDS, that control is super important because
Once you encrypt a DB instance with a specific KMS key, you can't change it later.
you got it. Choose wisely. So no pressure.
Noted. No takebacks when it comes to RDS encryption. Now, what about RDS read replicas? How do those factor into our encryption strategy?
Good question. If your read replica and its primary DB instance are in the same AWS region, here's the key point. You have to use the same KMS key to encrypt both.
So consistency is key for both security and functionality.
You got it. No mixing and matching keys for replicas in the same region. Another critical aspect. Key management. The guide really stresses using IAM policies and those condition keys to meticulously control access to your customer-managed keys.
Least privilege. It's like a broken record, but an important one.
It's true. The document even suggests using the KMS via service condition key with a specific RDS value
To ensure those keys are only used for RDS-related operations. So again, we're setting those boundaries, making sure the keys don't accidentally unlock something they shouldn't.
Exactly. And speaking of locking things down, remember those backups we discussed earlier?
Right. Backups. Always a good idea. But are they particularly important in the context of encrypted RDS instances?
They are. In really rare cases, Amazon RDS might, and I say might, temporarily lose access to the KMS key being used for your database.
Okay, that doesn't sound good. What would cause something like that to happen?
It could be any number of things, like a key being accidentally disabled or RDS access being revoked. It's rare, but it can happen.
So what happens if RDS loses access to the encryption key? Does my database just disappear?
Thankfully, no. The guide says the DB instance will go into a recoverable state. It gives you a grace period, 7 days to be exact.
Okay, so a little breathing room to figure things out.
Precisely. But here's where those backups become your best friend. If the instance still can't access the key after 7 days, it becomes inaccessible.
And the only way to recover your data from a backup. So it's like that spare tire in your car. You hope you never need it, but you're really glad you have it when you do.
That's a great analogy. And finally, for RDS, the guide recommends leveraging AWS config, specifically those RDs storage encrypted and ARDS snapshots encrypted rules. They're like automated checks.
Making sure those instances and snapshots are actually encrypted. It's like having a security guard on patrol, making sure everything is locked up tight.
Precisely. Anything else on RDS before we move on?
We've covered instances, replicas, backups. Are there any other RDS-specific tips, or are we ready for a new encryption adventure?
Just one more stop in the world of databases. We can't forget about Amazon RDS Proxy.
Right, RDS proxy. It's like that helpful intermediary between your applications and your database. What's the security angle there?
Well, the guide recommends using TLS to encrypt the communication between your application and RDS Proxy.
So no eavesdropping on those database conversations.
Exactly. And to make sure TLS encryption is in place, the guide suggests enabling the required TLS option right when you create your RDS proxy.
It's like a small checkbox in the setup process, but a giant leap for data protection. Any other RDS proxy advice before we move on?
Authentication is key. The guide is a big advocate for using IAM authentication for those RDS proxy connections.
So ditching those old school database passwords.
You got it. IAM authentication is more secure and centralized.
Plus, since RDS proxy supports IAM authentication, you can really put those least privilege principles into action.
Exactly. And with that, I think we've thoroughly explored the world of RDS encryption, from instances to read replicas, even RDS proxy. It's amazing how many layers of security AWS provides. Where to next?
I know. We've covered so much ground already. It's impressive how many different parts of AWS we can lock down with encryption. But I am ready for a new challenge. What's next on our AWS encryption journey?
Ready for a new challenge? How about we circle back to encryption context? It's powerful, but we need to use it carefully.
Okay, I'm all ears. Remind me again, how could encryption context accidentally weaken our security?
Remember how we talked about CloudTrail logs? Our security cameras diligently recording everything?
Right, those logs are essential.
They are, but they're stored in plain text JSON files. And that includes any encryption context you've added to your KMS keys.
Ah, I see where you're going with this.
Yeah.
We wouldn't want to accidentally expose sensitive information in those logs.
Exactly. That's the trap. The guide is crystal clear. Never, and I mean never, put sensitive information in your encryption context.
Got it. No personal details, secret keys, or anything super confidential in those context values. So it's for adding helpful information that helps with key management, but not something that would jeopardize the data itself.
You got it. Think of it like this. You're adding public labels to an already secure package, not writing secret messages on the outside.
Okay, that makes sense. So we're enhancing security, not creating new problems. Can you give me an example of using encryption context effectively?
Imagine you're organizing files. Encryption context is like using colored labels or folders.
So we can easily see At a glance, what's inside?
Exactly. You might include the application name, the environment like development versus production, or even the data classification level.
It's like adding metadata to our encrypted data, helping us categorize and manage it better.
Precisely. It makes organizing those keys, controlling access based on those labels, even auditing much smoother. You can even set up your IAM policies or key policies to grant access only to keys with a specific context, adding an extra layer of control.
Okay, that's cool. We're adding more specific permissions based on the type of encrypted data, even if the actual content is still secret.
Exactly. But just like you wouldn't deploy a firewall without testing it first, always validate your encryption context setup. Make sure it's working as intended.
Right. Don't just assume it's working, verify. This has been great. We've covered so much ground today. I feel like we've gone from being a bit intimidated by encryption to confidently navigating AWS. What else is on the agenda?
Well, next, let's talk about a service that's like a vault for your most sensitive credentials and API keys, Amazon Secrets Manager.
Ah, Secrets Manager. It's like a digital lockbox for those critical pieces of information we need to keep extra safe.
Exactly. And the guide emphasizes how tightly integrated Secrets Manager is with AWS KMS.
Okay, so tell me more about this integration. How does it actually work?
Essentially, it ensures your secrets are encrypted with unique data keys that are, in turn, protected by your KMS keys.
Yeah, like a bank vault inside Fort Knox.
I like the way you think. Now, when it comes to choosing the right KMS key for Secrets Manager, for most cases, the guide suggests sticking with the AWS Secrets Manager AWS managed key.
That's the default option, right? Any particular reason why that's the recommended choice?
For one, it's completely free to use. And since AWS manages it for you, it can lighten your key management load a bit.
Always a plus.
Yeah.
But let's say I want a bit more control. Can I still use those customer managed keys we talked about earlier?
Absolutely. If you need that extra flexibility, like granting cross-account access to a secret or applying specific key policies for auditing, a customer-managed key is the way to go.
Got it. So more control, but a bit more management overhead on our end. A classic trade-off.
Precisely. And remember that QMS.via service condition key, it's super important with Secrets Manager too.
Okay, so how do we use that condition key effectively with Secrets Manager?
The guide recommends setting its value to secretsmanager.region.amazonoz.com. It restricts the keys used to requests that are specifically coming from Secrets Manager within that specific region.
It's like we're telling those keys, you only work here, don't even try to unlock anything else. I like it. What other Secrets Manager wisdom is hidden in this document?
Remember when we were talking about the power of encryption context?
Right, like those colored labels for our encrypted data?
Well, with Secrets Manager, you can actually use specific keys or values within that context to set up even more granular access control mechanisms. It's like a secret handshake to access a secret society.
Okay, I love where this is going. Tell me more about this secret handshake.
You can actually build conditions within your IAM policies or key policies that are based on those specific context keys or values. So it's like you're adding an extra layer of authorization on top of everything else.
Double authentication. For secrets, love it. Okay, I think we've explored the world of Secrets Manager and its love affair with KMS. Where to next?
Let's talk about the backbone of data storage in AWS Amazon S3.
Ah, S3. It's like the bedrock of so many AWS deployments. But with all that data, especially sensitive data, it seems like S3 buckets would be a prime target for attackers. How do we keep them safe?
You're right, which is why AWS gives you a whole arsenal of encryption options. You'll be happy to know that Amazon S3 actually has a base level of encryption enabled by default for every single bucket.
Wait, really? So even if I don't configure anything, my data is still encrypted. That's reassuring.
It is. It's like having that basic security system that comes pre-installed in your new apartment. But just like with most things, you can always level up that security even further.
Okay, because who doesn't love extra security features? What other options are we talking about here?
You have SSE KMS, which lets you use those customer-managed KMS keys for more granular control. And then there's SSEC, which stands for server-side encryption with customer-provided encryption keys.
Okay, so at SSEC, I'm basically bringing my own encryption keys to the party.
You got it. You manage them, AWS never sees them, it's the ultimate in control. And some might say complexity.
So lots of choices for encrypting our S3 data. How do we decide which option is right for us?
It depends on your security requirements and how much risk you're comfortable with. If you're all about that extra control and auditability, SSE KMS is a solid choice. But if you need complete end-to-end control of your keys, then SSEC might be a better fit.
Right, so finding that sweet spot, balancing security, control, and manageability. Okay, what else can we do to lock down those S3 buckets?
One of the big ones is to deploy an Amazon S3 bucket policy.
Ah, bucket policies. Those watchful guardians, standing guard at the entrance to your S3 data.
That's a great way to put it. The guide suggests including the S3.xMM server-side encryption condition in that bucket policy. That way, you're making absolutely sure that all objects uploaded to your bucket are encrypted, no exceptions.
So, no sneaking past these guards with unencrypted data.
Exactly. And don't forget about securing those connections. Always use HTTPS to connect to your S3 buckets.
Okay, so no backdoors allowed. HTTPS or bust.
I like it. You got it. The guide even suggests using the AWS secure transport condition in your S3 bucket policies to enforce HTTPS.
Love it. What about access control? I know we can use ACLs, but those can get a bit messy.
You're right. That's why the guide recommends IAM policies instead. They provide a more centralized and, dare I say, elegant approach to managing permissions.
IAM, our trusty sidekick throughout this entire encryption journey. What about really, really sensitive data? What's our best line of defense?
For the truly sensitive stuff, the guide recommends using something called Vault Lock with Amazon S3 Glacier. It's designed for data that needs to be tamper-proof and worm-protected.
Worm-protected. Okay, now you have to explain what that means.
WORM stands for Write Once, Read Many.
So once that data is stored with Vault Lock, it's basically set in stone.
Exactly. Can't be modified or deleted, not even by the bucket owner. Ideal for long-term archives, compliance records, or anything else that needs to be preserved in its original state.
Wow. It's like locking something in a time capsule and throwing away the key.
Precisely. It's all about finding that balance between having options and choosing the approach that aligns with your specific needs and your organization's risk tolerance.
Right, because there isn't a one-size-fits-all approach to security. It's about building a strategy that's right for you. Okay, so we've covered Secrets Manager, dived into S3 encryption, and even unlocked the mysteries of Vault Lock. What other AWS services are on our encryption hit list?
Let's shift gears from data storage to networking and talk about Amazon VPC.
Ah, VPCs, those virtual networks that allow us to create those isolated environments within AWS. I bet encryption plays a big role in VPC security too.
Absolutely. And the guide has a lot to say about it. First things first, it stresses encrypting traffic between your corporate network and your VPCs.
So we're talking about securing the pathways between the outside world and our AWS cloud. How do we do that effectively?
VPNs are your friend. The document recommends using AWS site-to-site VPN connections.
VPNs, those secure tunnels we talked about earlier.
Yeah.
It's like we're creating a private encrypted pathway for our data, so we're not just sending it over the open internet, right?
Exactly. And if you happen to be using AWS Direct Connect, the guide suggests combining it with a site-to-site VPN for an extra layer of protection.
Defense in depth. Love it.
Yeah.
Now, what about those direct connections that support MAC-ESEC?
Those are great. MESEC actually provides encryption at the physical layer.
Whoa, so we're talking about encrypting the data as it travels over those physical cables. That's next level.
It really is. It's adding yet another layer of protection as your data moves between your network and your AWS Direct Connect location.
Okay, so we've got a few options for locking down connections between the outside world and our AWS cloud. What about communication within the VPC itself? How do we keep things secure within those virtual walls?
VPC endpoints to the rescue. The guide recommends using VPC endpoints, specifically with AWS Private Link.
So instead of sending traffic over the public internet, even within AWS, it stays on those private roads.
Exactly. It's all about avoiding those public highways where anyone could be lurking.
Secure and efficient. What more could we ask for?
Well, don't forget about security groups. They're like your VPC's personal bodyguards.
Right, our first line of defense.
Exactly. The guide emphasizes configuring those security group rules to allow traffic only from ports associated with secure protocols. HTTPS on port 443, for example.
So no shady characters sneaking in through those unsecured ports.
Exactly. And just as important as setting up those security groups is regularly auditing them.
All right, we can't just assume they're working perfectly forever. We need to check in, make sure those rules are still relevant, and make sure no one's been messing with our settings.
Exactly. Security is a journey, not a destination.
So true. Okay, I think we've thoroughly covered the world of VPC encryption. Where to next?
We've talked about securing data at rest in transit, but what about when it's being used?
Right. It's not enough to just protect it while it's being stored and moved around. We need to make sure it's secure while it's being processed as well.
Exactly. And that's where tools like the AWS Encryption SDK shine. They give developers the power to encrypt data within their applications even as it's being actively used.
It's like having that security detail follow your data everywhere, making sure it's protected 24/7.
I like it. Now, when it comes to using the AWS Encryption SDK, the guide emphasizes sticking to best practices.
So no trying to reinvent the wheel when it comes to encryption.
Exactly. The AWS Encryption SDK already uses industry standard algorithms and best practices, so we don't need to start from scratch.
Got it. So what are some of those best practices we should be following?
One thing it emphasizes is using wrapping keys to protect your data keys. It's an extra layer of security, like putting your house keys inside a safe.
Double the protection. Okay, that makes sense. What other best practices do we need to know?
It reminds us about the key-ID parameter, especially when we're using the AWS Encryption SDK's re-encrypt operation.
Right, because we want to make sure we're using the right key for the job.
Exactly. Passing that key-ID parameter helps prevent accidentally using an untrusted or incorrect KMS key.
It's like that extra layer of verification, making sure the key actually fits the lock before we try to turn it. Now, I'm imagining a scenario where our application is handling a ton of traffic with encryption and decryption happening constantly. That seems like it could get pretty intense from a performance perspective.
Absolutely. And that's where the AWS Encryption SDK's data key caching feature comes in.
Right. It's like we talked about earlier. Keep those frequently used keys handy so we're not making a trip to the key master every time.
You got it. But, and the guide stresses this, make sure you configure those cache security thresholds carefully. The last thing we want to do is sacrifice security in the name of speed.
Right. We're not making that trade-off. It's about finding that balance, caching strategically, but not opening ourselves up to unnecessary risks.
Exactly. Now, we've talked about using the AWS Encryption SDK to build encryption into our applications, but before we go any further, we need to zoom out a bit and talk about a crucial aspect of security that underpins everything we've talked about today:
What's that?
logging and monitoring.
Yes. Logging and monitoring. It's like having those security cameras and motion sensors for our entire AWS environment.
Exactly. You can't just set it and forget it. We need to keep an eye on things.
So what are the key takeaways from this guide when it comes to logging and monitoring, especially for encryption-related activities?
First and foremost, use the power of AWS CloudTrail.
CloudTrail, our trusty audit trail for everything that happens in our AWS account.
The guide is clear. Enable CloudTrail logs for all your critical AWS services, especially the ones handling encryption and key management.
So if someone tries to create a new KMS key without permission, disable a key, or even just change a key policy, CloudTrail will catch it.
You got it. It's like having that detailed security footage in case you ever need to go back and investigate a security event.
Or if we need to prove compliance, always a plus.
Absolutely. Now, on the monitoring side, the document recommends setting up alerts for those key events. Key creation, updates to your customer-managed key policies, even attempts to import key material.
Okay, so we're talking about being proactive, getting alerts if anything suspicious happens.
Precisely. And it doesn't stop there. The guide even encourages us to automate our responses to these events.
Okay, now we're talking. So it's not just about knowing something's wrong. It's about automatically taking action to fix it.
You got it. Automating those responses to security events using Lambda functions, for example, can dramatically strengthen your security.
It's like having that security system that not only detects the break-in, but also calls the police for you. I like it. What other tricks does AWS have up its sleeve to help us manage all of this?
The guide also recommends using AWS Config. Think of it as having a continuous security and compliance check running in the background.
It's like that super organized friend who always makes sure everything is in order.
Oh, that's a great way to put it.
Uh-huh.
AWS Config constantly monitors your AWS resources to make sure they're complying with your predefined rules and those all-important security best practices.
Okay, so it's not just monitoring. It can actually do something about it. If it finds any issues, that's awesome.
Exactly. It can even automatically remediate issues it finds, which is incredibly powerful.
So how does this tie into encryption specifically?
The guide recommends using AWS config rules to ensure your resources are actually encrypted correctly. For example, you can use the S3 bucket server-side encryption enabled rule to make sure your S3 buckets have server-side encryption enabled.
Okay, so it's like having a safety net. Even if someone forgets to enable encryption, AWS config swoops in and saves the day.
Precisely. And you can use AWS config rules for so many other encryption-related tasks.
So AWS Config is like our silent security partner, working behind the scenes to keep everything running smoothly. But before we get too comfortable, what about data classification? We touched on it earlier, but I feel like there's more to it than just slapping labels on our data.
You're right. Data classification, it's the foundation of your whole security strategy.
Right, it's the why behind all of these tools and best practices we've been talking about.
Exactly. It's about understanding how sensitive your data is and applying the right level of protection based on that sensitivity.
Okay, so again, not all data is created equal. We wouldn't protect our grocery list with the same intensity as the recipe for Coca-Cola.
Exactly. The guide emphasizes that data classification is about context, the potential impact of a breach, and regulatory requirements. It's about asking, what kind of data is this? How bad would it be if it fell into the wrong hands?
So understanding the value of what we're trying to protect and then applying the appropriate level of security.
Precisely. Once you've classified your data, you can start applying all those encryption best practices we've been talking about.
It's like building a house. You need a solid foundation, data classification, before you can start adding walls and a roof, encryption best practices.
That's a great analogy. And here's something crucial to remember. Data classification isn't a one-time thing.
So it's not like we can just classify everything once and be done with it.
Exactly. It's a living, breathing process. It needs to be revisited and updated as your business evolves, as new data emerges, and as those pesky regulations inevitably change.
So data classification is a journey, not a destination, just like security itself.
You got it. And remember, data classification isn't just about protecting your data from external threats. It's also about internal security, making sure only authorized people within your organization can access sensitive information.
Right, like having different levels of security clearance, top secret, confidential, and so on.
Exactly. Data classification helps you implement those fine-grained access control mechanisms we've been discussing, ensuring that the right people can access the right data at the right time.
It's like all these pieces fit together. Data classification, encryption at rest, encryption in transit, secure key management, logging, monitoring, automated responses. It's an entire symphony of security measures working together in harmony.
That's beautifully put. And while encryption is a crucial instrument in that symphony, it's not the only one.
Right. It's not a magic one. We need a holistic security strategy, right? Thinking about all aspects of our AWS environment.
Absolutely. And this guide does a great job of laying the foundation for building that comprehensive security strategy.
I'm feeling much more confident about our AWS security posture now.
That's what we like to hear. What other AWS encryption adventures are you ready to explore?
Okay, you've convinced me. Data classification is crucial. Where do we go from here? Any other AWS encryption essentials on our list?
Absolutely. We've covered a lot of ground, but there's always more to explore. Ready for another deep dive?
Bring it on. I'm ready to expand my AWS encryption knowledge even further.
Okay, then let's talk about a service that's often overlooked but plays a crucial role in securing your cloud infrastructure.
Ooh, I love discovering hidden encryption gems. Tell me more.
Let's talk about AWS Certificate Manager, or ACM for short.
ACM, okay. I know we need certificates for things like HTTPS, right, to make sure those connections to our websites and applications are secure.
Exactly. ACM makes it super easy to provision, manage, and deploy those public and private SSL/TLS certificates.
So it's like having a one-stop shop for all our certificate needs. That sounds convenient.
It is, but here's where the encryption angle comes in. ACM integrates seamlessly with AWS KMS.
Okay, I'm sensing a pattern here. KMS really is the key master of the AWS universe.
It really is. And when you use ACM to request a private certificate, one that you'll use within your own private networks, for example, you can choose to have that certificate's private key protected by a customer-managed KMS key.
Ah, so we're bringing in those fine-grained access controls and auditing capabilities we talked about earlier.
Precisely. It's all about layering those security measures and making sure you have that granular control over who can access and use those certificates.
And what about those public certificates? The ones we use for securing our public-facing websites and applications?
Good question. For those, ACM actually takes care of the key management for you.
Okay, so it's like that set it and forget it level of security, but for our public certificates.
Exactly. ACM automatically handles things like key rotation and security best practices, so you can focus on other aspects of your cloud infrastructure. Now, here's something to keep in mind with ACM. It's not just about requesting new certificates, it's also about keeping track of those expiration dates.
Because no one wants to deal with an expired certificate. Those can really bring things to a screeching halt.
You said it. Luckily, ACM makes it easy to stay on top of things.
Okay, Tell me more about these magical features. How does it actually help?
It provides notifications and even automated renewal options.
So ACM is like that proactive assistant, reminding us to renew our certificates before it becomes a problem.
Precisely. It's like having a built-in safety net to make sure your encrypted connections stay secure. Now, since we're talking about certificates, we can't forget about another critical aspect of security:
Which is?
key rotation. Regularly rotating your encryption keys is a fundamental security best practice, and ACM makes it a breeze.
Okay, convinced. Key rotation is important, but why is it so crucial? I think some people might see it as an unnecessary hassle.
Think of it like this. The longer an encryption key is out there in the wild, the more opportunities there are for attackers to try to compromise it. Regular rotation helps mitigate that risk by reducing the impact of a potential key compromise.
So it's like changing the locks on your doors every so often, just an extra precaution to deter those would-be intruders. And ACM helps us automate those lock changes.
Exactly. You get it. It's about staying one step ahead of those bad actors.
Okay, I think we've covered ACM and the wonderful world of certificates. What other encryption adventures are we ready for? We've covered so much ground already. It's amazing how many different parts of the AWS ecosystem rely on encryption in some way. But I'm always up for a challenge. Where to next?
How about we step back and talk about something that underpins so much of what we've discussed today?
Ooh, I love a good connecting the dots moment. What are we connecting back to?
Let's talk about shared responsibility.
Ah, yes, shared responsibility. It's one of those cloud computing fundamentals, right?
Exactly. And it's especially relevant when it comes to encryption in AWS. The guide repeatedly emphasizes that security is a shared responsibility between AWS and you, the customer.
Okay, so it's not as simple as AWS handles the security and we just sit back and relax.
Not quite. While AWS takes care of securing the underlying infrastructure, things like the physical data centers, the hardware, the network, you, as the customer, are responsible for securing everything you build and run on top of that infrastructure.
So it's like AWS provides the secure foundation, and then we build our secure house on top of it.
That's a great analogy. You're responsible for configuring your services correctly, managing your encryption keys, setting up access control policies, all those best practices we've been talking about.
Right, because we're the ones who best understand our own applications, our data, and our specific security needs.
Precisely. AWS provides the tools and the guidance, but it's up to you to use them effectively. Now, here's something important to remember about shared responsibility. It's not a static thing. It can actually vary depending on the specific AWS services you're using.
Okay, so tell me more about this. How does shared responsibility actually play out in the real world of AWS services?
Take S3, for example. With SSE S3, where AWS manages the encryption keys, AWS takes on a bit more responsibility for key management. But if you opt for SSE KMS and use customer-managed keys, you're taking on more of that responsibility yourself.
So it's like a sliding scale. The more control we want, the more responsibility we assume.
Exactly. And the guide does a great job of outlining those responsibilities clearly for different services, so there are no surprises. Understanding the shared responsibility model is crucial for building a secure and compliant AWS environment.
Absolutely. No more pointing fingers and saying, but I thought you were handling that.
Exactly. It's about having a clear understanding of who's responsible for what, so you can focus on your part and build that secure cloud infrastructure. This has been great. We've covered so much ground: KMS, S3, VPCs, Lambda, RDS, Secrets Manager, IAM, even those fundamental concepts like data classification and shared responsibility.
I told you I was ready for a challenge. This deep dive has been incredible. But all good things must come to an end, right?
They do. But here's the thing about encryption. It's not a one-time thing. It's an ongoing process. And the best thing you can do, never stop learning. The threat landscape is constantly changing, and so are the tools and techniques we use to protect ourselves.
You've given our listeners a lot to think about today and hopefully a lot to put into practice.
I hope so too. Remember, encryption is your ally, not your enemy. And with the right knowledge and a proactive mindset, you can confidently secure your data in the cloud.
Well said. And with that, we've reached the end of our AWS Encryption Deep Dive. It's been an absolute pleasure exploring these topics with you.
The pleasure was all mine. Until next time, stay curious, stay secure, and keep innovating in the cloud.